The title was something like Simple Operations Management Techniques. All right, now these techniques are in reality not as simple, but we're obviously simplifying them for you to get the idea, to understand what is going on. And these techniques are simple, yet they could be very effective and very powerful. Remember that simple does not mean useless. Actually, in most cases, the most effective solutions and the most effective techniques are the simple techniques, the ones that people can easily understand and they can easily apply, as opposed to techniques that are extremely complex and complicated, and they would look very good on paper, but we cannot really apply them. So, although the second module title says Simple Techniques of Operations Management, we have already mentioned that, or I mentioned that, these techniques revolve around one theme, which is really the capacity theme. So last week, for instance, we talked about simulations. The week before, we talked about process requirements, capacity requirements. In both of the techniques that were discussed, the primary concern, the primary application of those techniques was determining, estimating process capacity. And that's because the process capacity is, and therefore the system capacity is fundamental to the management of the entire production system or service system. In the end, I need to know if my capacity is going to meet the requirements, the demand requirements. And I've already mentioned this, and I'm going to keep mentioning it over and over, which is that when it comes to determining the capacity of the system, this decision is critical, because if we produce more than the demand, that is a problem, because we'll be producing a lot of products that the customers don't want. No one is buying, and we're going to end up with a lot of junk sitting in our warehouses, a lot of inventory that has no value, that has no use. At the same time, if we produce less than what is demanded, that is also problematic, because we'll end up losing a lot of customers that come looking for the product and they don't find it. And that is a missed opportunity. It is also a lost market share. We end up losing market share. So trying to determine the appropriate levels of capacity is very, very important for us, is very critical. One way that we already considered that was in determining the requirements. For example, determining the number of machines that would be required, that would be needed. Okay. For instance, when we looked at the simulation last week, we looked at the decisions we control and we can make in order to maintain capacity levels that are, adequate to the demand levels that exist. And we looked through simulations at, complex systems where the relationships cannot necessarily be described explicitly in mathematical form, right? So in that example, we also talked about, the capacity issue, whether it's in production or as a distributor. In the end, it's also a question of capacity when you talk about how much you bring in versus how much you send to your own wholesalers or retailers or what have you. So that's pretty much what we have discussed in the last 2 weeks in relationship to, module 2. And that leads us to the introduction of today's topic. Now, today's topic is also related to the discussion about process capacity from a slightly different angle. In particular, in terms of the setting of standards or setting of targets. Like, for instance, you hear, in a lot of, examples when we talk about, for instance, employee productivity, or when we talk about evaluating the performance of employees, we usually talk about, have the employees met their targets? Well, the question that we will address today is, how do we set those targets? How do I set the targets for the employees in terms of, for instance, production? How do I determine whether the employee should produce 100 units in 1 hour or 50 units in 1 hour? Because you see, there is a lot of, decisions that will depend on that. For instance, determining how many an employee is supposed to produce in a given period of time, well, that is essentially an indication of how much the system will be able to produce, and that is the capacity. So are we going to be able to meet the demand or not? This is one decision that is dependent on that. The decision on how many employees to schedule. Okay, if I say, for instance, every employee must be able to produce 100 units. My demand is 500 units, so therefore I will schedule 5 employees, because 5, 100 each. So the decision on that setting of the target determines also another decision, which is scheduling or staffing. It also affects, other related decisions in terms of, for instance, the performance evaluation. You see, when I set these targets for the employees, at the end of the cycle, at the end of the month or quarter or year, okay, at the end of the year or the end of a given cycle, I need to evaluate the performance of the employees. And that evaluation will depend certainly on those targets, because the way it's going to work is that if the employee meets or exceeds their targets, then they are evaluated as doing a good job. On the other hand, if the employees do less than the targets, then we will think that they did not do a good job, and then there are other decisions that will follow, which is either like more training, more development. The whole question here is that, well, what if the targets are incorrect? What if the targets I'm setting for the employees are wrong? That means I'm saying that the employee should produce 100 units per hour, but realistically, there is no way an employee can make 100 units in 1 hour. It's just impossible, all right? Or on the other hand, if I say that the employee should be able to make 100 per hour, where our competitors, their employees are able to make 200 per hour. So in that case also, I'm going to be, asking the employees to do much, much less than they can. And that is also problematic because it's costly for the company. I'm going to end up hiring more people than I actually need. So it's a very important decision, deciding on these standards or targets. We usually describe these in terms of time standards, or the standard time to make a certain product or to provide a certain service. Like, for instance, if I say that an employee can make, okay, let me share my screen with you. All right. If, for instance, we say that an employee, can make 60 units in 1 hour, okay, then what we're saying is that the employee is on average taking 1 minute per unit. So we're saying that the standard time that an employee should take is about 1 minute per unit. Now, determining this standard time, determining this time is the focus of today's lecture. How do we do that? How do I accomplish, how much, time does an employee need to carry out a certain activity? That is the purpose of today's lecture, and we're going to explain it later in more detail. But let's start with an example that is probably more relevant to you as students. Like, for instance, one of the things that we always have to deal with is in an exam setting or and so on. A student says, we did not have enough time to answer the question. Now, this is a valid question. How do I set the time it takes for a student to write down his or her answer? Okay, now obviously students have different capacities, but if I focus on only one aspect of the question, which is, suppose we're talking about what we're doing now, which is blended learning. And like, for instance, you're going to have, you have certain assessments where they ask you, for instance, to type your answers directly into SULMS. Now, in that case, I mean, how do I decide as a teacher whether to give you 10 minutes for the question, or to give you 15 minutes, or to give you 20 minutes, and so on and so forth? All right. So the idea here is that, how do I determine that time for which I believe it's fair for the student to write down the answer to that question, all right, and have, adequate time to answer the question? Well, one way to do this is actually to carry out what we call a time study, okay, where I try to model, okay, what is it that exactly the student does when they write down their answer, okay? If they need to type it, you can find out how much time would it require to type an answer of certain characteristics. Like, for instance, I can be looking for, the time study to determine how much time is needed for a student to type an answer. For example, we want to determine just the typing part of the answer. How much time does the student take to type a model answer of a certain number of words, for instance? All right. Now, how can we do that? Well, one way to do that is to carry out an experiment, for instance, and we're going to actually, carry out this experiment right now. Let's say, okay, we have, let's say, the following sentence. This sentence is from the lecture, okay? I want to find out in this group, okay, on average, how much time does it take for a student to type a word? Because now, when you look at a given assignment, usually, okay, the assignment is given, or the question or the answer is given in terms of the number of words. So what if I carry out now the following experiment? If I ask each one of you to type this sentence and record how much time it takes you to do that. Okay? Well, first of all, let me count how many words. Okay? It's very clear that there are 17 words in here. So there are 17 words. So we're gonna, do this. This is a simulation. This is an exercise. If you are using your computer or using the telephone, type this sentence and record how much time it takes you to do that. Like, for instance, I'm gonna tell you, in my case, okay, I'm gonna do the following. I'm gonna use a stopwatch. You know what stopwatch is? Okay, I'm gonna use a stopwatch. I'm gonna type the sentence and record how many seconds it takes me to write this sentence. Okay, so for instance, I'm gonna click start and start typing. The process of creating labor standards based on the judgment of skilled observers is called time study. Stop. All right. It took me, for instance, 32 seconds. So we're going to record this data. Okay, Dr. Sadouli. It took me 32 seconds. Okay. Now, can you do this experiment and tell me how much time it took you to write this sentence, to type this sentence? This is a time study experiment. All right, this is a time study experiment. So what we do is we ask the people doing the work to actually carry out the activity, and we time them. Like in this case, I'm asking you to type the sentence and tell me how much time did it take you. It took me, for instance, 32 seconds. Okay, can you tell me how much it takes you to do this?
Wait, doctor, we will try.
Yes, I'm gonna give you some time to do it, yes. So you can take, a couple of minutes and try to do this, and you can report your answer using the conversation here. You can just, so that we don't have Okay, so Saeed, 46 seconds. Saeed, 46 seconds. Okay, Badriya, 55. Maimuna, 31. It's very good, okay? So say an exercise, Maimuna, 31 seconds. Okay. Can I have a few more so that, we can get a meaningful average out of this? Okay. Taif has 49. Wa'ad, 44. Asma, 52. Okay. So I have 3, 6, 7. Maybe if you can have 10, that will be great. We can have maybe 4 more. Actually, 3 more will do. We can have 3 more. Marwa, 42. Okay. Two more. So I have 3, 6, 8. Okay, out of 34 attending, we can have 10. Come on, we only need 2 more, okay? All right, never mind. We can work with the 8 values that we have. Okay. So in the time study, you see what we did? It's exactly what we did right now. So I ask the students, for example, in this case, to type like a standard sentence in this example, like the one we have in this example, and in determining the time, okay, before we actually decide that we will provide this much time or this much time, there are certain factors that we need to take into account. Now, these are the times obviously for 17 words. So if I want the average time per word, I will take the time divided by 17. So for instance, like 1.88, then 46 by 17.
2.705.
Now, obviously, we can always be a little bit more efficient, and we can simply do this in Excel. Okay, we can do this in Excel very quickly. And we're going to do this. This is equal to this divided by 17. And so that we don't waste too much time on this, let's have just 2 decimal points. So there we go. Copy, and we're going to paste it down here. There we go. All right, so now we have an average time per word in seconds. Okay. Now, should I immediately go here and say, well, then I'm going to use this particular time? All right, so the average time per word, okay, for the sample, for the whole sample, I'm going to take the average of all of these. We can do this easily here in Excel. Okay, we'll just take the average of these values. And that gives me 2.58. Now, the question is, should I now therefore base my decision simply on this average time that I determined? Well, we have to be maybe a little bit more careful, because when we do this experiment, okay, there are, 2 issues. One is that while you're doing this, you were keeping track of your own time, and probably, the reading might not have been very accurate. So I could have maybe 1 or 2 more seconds in some of these. The other thing is that in doing this experiment, this is not the normal time, okay, or the normal feeling that you have during an exam. In the exam, probably you'll be a little bit more stressed, and instead of taking you 40 seconds to write this sentence, because of the stress of the exam, it might actually take you a little bit more. Maybe it's going to take you 10% more time or whatever. Typing with a on a mobile phone, for those who are using their mobile phones, okay, it's not as convenient as typing on the keyboard. So therefore, I cannot just take this time and take it as it is and use it to determine the time standard or the standard time I'm going to use for the students. I have to be a little bit more careful about this, which is that I need to include in this the fact that there are certain factors that are affecting this time, okay, either making it longer than it normally is or making it shorter than it normally is. And to do that, we have something called the rating factor. The rating factor, or the RF, is a factor essentially that we use to either increase the time or decrease it. Like in this case, do you think that the average time per word during an exam setting, okay, when you're doing this in the exam, do you think that you'll take more than the 2.5 seconds or less than the 2.5 seconds per word? Intuitively. More, exactly. And therefore, the rating factor in this case must be more than 1. So, we might take 10% more, might be 20% more, okay? That's what the rating factor does. The rating factor essentially takes into account, okay, the fact that, okay, or the setting takes into account how different is the experiment setting from the normal setting. What does this mean? Well, it means that when I carried out the experiment, is this the normal situation? Is this the normal conditions? If it's the normal condition, then the rating factor should be 1 because it's the normal condition. Whereas if it's not the normal condition, like in this case, you're doing this, and this is definitely different from the setting during an exam. So, as your colleague just said, most likely we will take a little bit more during the exam because of the stress of the time, because of the pressure, whatever it is. So, in order to calculate now the normal time, we'll need to take that average time and multiply it by a rating factor. Like for instance, okay, let's say in this example, suppose that the rating factor is, let's say, 1.25. What does this mean? Well, it means that on average we expect that on average during the test, the student requires 25% more of the time due to the pressure of the exam, due to the stress that is in the exam. So we use this to determine a normal time, and we will do something like this. So we'll take the average time that I recorded multiplied by the rating factor.
3.225.
3.225 seconds. So now we see this is the normal time to type one word, using or including in it the setting of the experiment and how different it is from the normal and so on and so forth. So now, if a question requires, an answer of, let's say, 250 words, then the normal time for the question, how much time should I give for this question? The normal time for this question. Okay, remember that this is 3.22. This is per word. If I'm expecting an answer of about 250 words, then what should be the normal time for the question? Because this is the time per word. If the question requires 250 words, the normal time for the question, how much time should I give for this question?
806.25.
Very good. How did we get that?
Multiply.
Correct. 3.225 multiplied by 250. So we get, you said 806.25. Okay. Which is, how many seconds? Divide by 60 so that we get seconds. How many minutes? Sorry.
13.
13, about 13 and a half minutes, almost. Okay. Now, the other thing is that, okay, now this is the normal time for the question. That means if the student is only going to actually type, that means he has the answer ready, he's just going to type it. But is that really the case in the question, in the exam? No, because I need some time to think about the answer before I type it, right? So this is why we give an allowance, okay? We give an allowance for thinking about the answer, because the student will think about the answer, then they will type it. All right, and this is, you know, the importance of taking these things into account. And in order to calculate, therefore, the standard time, okay, it will be the normal time for the question, and we multiply it by, like for instance, if we need to, on average, we think that the student requires, you know, 50% of the time to think about the answer. What does that mean? So it means if the normal time to type is 13.5 minutes, how much time should I give the student to answer the question now, to actually think about it and type it? Well, it will be 13.5 multiplied by 1 plus 0.5. It's the 13.5 that he will need. In other words, let me actually write it maybe in a simpler form. It's gonna be 13.5, which is the time the student needs to type, and 13.5 times 0.5, which is half of that time, to think about the answer. So this is the time to type. That's what we determined. Because you see here, I just asked you to type. You did not think about it. You just typed it. So this time here is only the time to type the question. We are adding an allowance for thinking about the answer. Let's say in this case, I'm saying that it's 50% of the time is needed to think about the answer. So the total time, the standard time that should be given for this question should be 13.5 for typing, and half of that, 50% is half of that for the thinking about the question. What do we get here?
20.25.
5 minutes. And this is our standard time. So therefore, this would be a scientific method of determining how much time I should give to the student in order to answer the question. Obviously, there are some assumptions we have made here. For instance, here I'm assuming that the student requires only half of the time to think about the answer as much as he needs to type. It may be actually the other way around. Maybe that the student needs twice as much to think about it than to type. In that case, this should be 200% instead of 50%. Everything that you see in the lecture is pretty much what we did here. This is the whole idea behind time study. We ask the people who are doing the work to actually do it. So we break it down into smaller components. Like in this case, I didn't determine the time for the entire question as one, shot. We divided it into smaller pieces. We said, okay, how much time it takes to type a word? If the question has this many words, 250 words, how much time it takes to type those many words? Then we took into account the fact that, the time we, type this during the exam could probably be more than the time it takes during the session, because now you're feeling comfortable, you can do this, and you're not, worried about the actual, correctness of the question or the answer, and you're just, being not as careful. All right, so that's what the idea of a rating factor is. And then we determined the normal time for the entire question. It's like the normal time for the entire cycle that you see in the lecture. How do I do that? Well, it's the time for one word multiplied by the number of words. Like the lecture says, the time for one cycle multiplied by the number of cycles. Okay. The allowance, and then you calculate eventually the standard time, and we come up with, for instance, 20.25 minutes in this example. Okay. This is a time study experiment. Now, in the application to, production systems, okay, the way this works is that I will do a similar thing, which is, if I'm, for instance, determining, or let's say I'm looking at an employee at a coffee shop, the barista, the person who prepares the coffee. Okay. In order to determine how much time it takes him to prepare 1 cup of coffee. Okay. Again, I need to break down that process to the different, work elements that make up that activity. Like for instance, to make the cup of coffee, the first thing is that they will get that coffee holder, okay, clean it if it's not clean, then they would fill it with the ground coffee. Okay, when you go to the coffee shop, you see that they actually they take the that coffee holder, they fill it, okay, then they put it in the machine, in its slot in the machine. They press the button or they pull down the lever, okay, then they add the foam or whatever, if this is like a cappuccino or macchiato or whatever, and then they clean their workspace. So you see what we did? We took the entire operation of preparing a cup of coffee and we broke it down into the various work elements, because this makes the measurements more precise and makes the measurements more reflective of what the employee actually does. So now here, for instance, I can actually measure specifically. For instance, it takes the guy, let's say, 30 seconds, okay, to clean and fill the holder with coffee. It takes him, 10 seconds, for instance, to put the ground coffee. It takes him, let's say 30 seconds to get the coffee, made by the machine. It takes him 30 seconds to add, for example, the foam and whatever other additional things. And it takes him another, let's say 20 seconds to clean his work area and provide a completed cup of coffee. So to find how much time it takes to prepare the cup of coffee, what do? Well, we just add these. We add the time for the various work elements. Obviously, before we do that, I need to determine, are the rating factors 1 or not? Is the work done here under normal circumstances, the usual circumstances that the employee will have when they have customers? Okay, like for instance, if you are working in the morning, when you first open, okay, you might not know this, but the machine, for instance, takes some time to warm up so that it can actually make a cappuccino, otherwise it will not work. Okay, so we will do this and multiply by the rating factor for each one of them, and then you're gonna add all of these to give you the normal time. And that's what the formula that is, we're gonna look at the formula in a minute in the lecture. That's exactly what it does. What you do is you take the time that is measured, you multiply it by the rating factor, which is taken into account whether the operation is taking place under normal circumstances or not, and also multiplying it by the number of times that or actually dividing it by the number of times that that particular part or that particular task is carried out. Like for instance, when you look at a lot of these coffee shops, okay, when preparing the coffee in the machine, actually the machine can, with the same run, have 2 cups of coffee. So in that case, the 30 seconds here is not only for 1 cup, it's for 2. So in that case, I have to divide this actually by 2. And each cup, because if I'm looking for just 1 cup, okay, each cup will only take on average 15 seconds, not 30. All right. These are the ideas behind the time study. That is the objective of this week's lecture. So before I go on to discuss the lecture in a little bit more detail, are there any questions about what I have discussed so far? Is this making sense? Yes, no, maybe, perhaps. Yes, okay, thank you, Wad. I need you to sometimes say something so that I know that there are people out there, because all I see is a screen full of names. Okay, so please, even a yes or a no will do sometimes, so that I know I'm not talking to myself. All right, so there are no questions, it seems. The time study is the process of creating standards, labor standards, based on the judgment of skilled observers. So if we project this definition to what we have done, the experiment we have done, okay? We created this labor standard, this standard time for answering a question, through the observing of your performance in writing these sentences. That's what the definition says. Based on observing. Observing what? Observing the people doing the work. All right. Obviously, for the results to be more, accurate, we need to have skilled observers. Like, for instance, as I said earlier, when we are taking these values, these measurements here, none of us is a skilled, time taker, because by the time probably I pressed start and by the time I pressed, stop, I might have actually added, 2-3 more seconds. Now, some of you might say, well, what's the 2 seconds or 3 seconds, what difference will that make? Well, because, when you're talking about questions that have 200 words and 250 words, even fractions of seconds start adding up. All right. So it's the same when we're talking about manufacturing or service. All right. That, differences of 2-3 seconds, especially when you're talking about an operation that has a number of work elements. If you have like 2-3 seconds added in each one, you're going to end up with, an additional maybe 10-15 seconds. And when you're doing this in 1 hour that has 3,600 seconds, and you're doing this for 8 hours a day, and you're doing this for so many employees, you can see that the numbers actually start building up. And that is, you might end up actually wasting a lot of money and a lot of time simply by being inaccurate in collecting the measurements. So that is the idea here, why this emphasis on skilled observers, why we are interested in skilled observers. The steps was exactly as pretty much what we did. First of all, selecting the work elements. Like in our exercise, we said, okay, we're gonna write this sentence, okay? And we're gonna assume that each word really represents a work element in a sense. We measure the time of the work elements. So what we did was exactly that. We measured the time for the work elements. And in our case, to be able to do this, because realistically, I cannot just give you one word and ask you to type it and at the same time take a measurement. I don't think will be that accurate. So we did this, procedure where I'm doing 17 words and then I'm going to take the average to find the time per word. And this measurement of the work elements provides the basis for setting up the standard time. This is the formula. Okay, we have already indirectly applied it really, because what we did was the normal time is the measured time multiplied by f, which is the frequency, the number of times we repeat something, multiplied by the rating factor, Okay, so in our example, when we calculated this normal time, we said, okay, the rating factor is 1.25, but also we are talking about one word. So therefore, the F, the frequency is only one. I'm talking about the number of words only per word, for only one word. The normal time for the whole cycle is like what we did here, which is the normal time for the entire question. The sum of the times for all the cycles. In our case, I have 250 words. Each word is 3.225. So therefore, it's the sum of the 3.225 250 times, or 3.225 times 250. All right, that's what the normal times for the whole cycle, normal times for the complete cycle. The allowance is the additional time that we have, okay? For instance, in our case, we said that's the time that you have for thinking about the answer. Because you're not gonna just type, you need to think about the answer. In the real, in other examples of, for example, production system or a service system, that allowance could be, that the employees, when they are working, on average, they might take, some time to breathe. Sometimes they need, they have a break. They can take a break for prayer. They can take a break for, a lunch or whatever. So we take that into account, and we usually specify that as a percentage. 20%, 10%, 15%, whatever it is. It depends on the situation. Okay, like for instance, let's say in our case, just to give you an example, okay, we are supposed to work 8 hours, out of which we have half an hour of a break. We have half an hour break. So that gives us 6.25% allowance. In our case, that would be our allowance. Okay. Someone who's working, for instance, for 10 hours and they have 1 hour break, that will be an allowance of 10%. Okay. So to determine the standard time, that's exactly what we do. We take the normal time for the complete cycle, multiply it by 1 plus the allowances. Like I'm taking the normal time and adding to it the allowance I'm using for, whatever time that is taken that is not directly involved in carrying out the activity, in doing the task. All right, that is the formula. As an example, okay, in this case, it clearly says what is T, what is F, what is RF. But if you do not have these mentioned in there, then you can typically, tell. I mean, T is the time in minutes. F is the frequency. How many times is it done? Like, for instance, when you look at the first work element here, it says get 2 cartons. All right. That's why F is only 1/2. Why? Because I have 2 cartons. So the time for only 1 pack will be half of the time I take for the 2 cartons at the same time. That's why this is 1/2. Whereas the others, put the liner in carton, it's per carton, so the frequency is F is only 1. Okay. Now the RF can be either more than 1 or less than 1, by the way. Okay, it could be more than 1 if we believe that the time that we measured, okay, is less than the normal time. So we need to increase it a little bit more. Like for instance, when would that be the case? If, for instance, I used the most efficient employee to do this. Not everyone is as efficient in doing that. Okay. If, for instance, I used this when the inventory of cartons was full, so therefore I could get the cartons, much closer to where I am. I did not have to walk further. That would be an example. It could also be a little bit more. If less than 1, when we believe that the time we measured, okay, is actually more than it usually takes. All right, like for instance, maybe that the employee who was doing that at that time when we were observing him, like it was towards the end of the day and they were becoming a little bit tired. I cannot base my decision on that, so I need to maybe reduce it a little bit by about 5%, as you can see here, and so on. So in calculating the normal times, the NTCs and the standard time, the formula is very clear. The normal time for each element, so we have each element 1, 2, 3, 4, is simply the T times F times rating factor. So 0.53 times 0.5 times 1.05, that's 0.28 minutes. It's 0.28 minutes per work element or per carton in our example. Okay. Same thing for the second element, work element is 0.095 minutes. Then it is 0.083 minutes. Then it is 0.97 minutes. This is the normal time. For the complete cycle, it's like for the entire process, like the example I gave you earlier. For the whole thing, we're gonna add them up. We need to add all of them. So the NTC is simply the sum of these, 0.28 plus 0.095 plus 0.83 plus 0.97, all the way to, gives us a 2.18 minutes for the normal time for a complete cycle. This is the normal time. What do we need to take into account? Well, we need to take into account the allowance. Like here, we are told that for this company, the allowance is 0.15. That means 15%. So therefore, to find the standard time, we will take the normal time for the complete cycle multiplied by 1 plus 0.15. So it's the normal time plus the allowance time, and this gives us 2.507 minutes per carton. Okay. Now, as I said at the beginning, this is usually used to make some further decisions. Okay, like when I have the standard time, based on this, now I can make this value for setting targets. So now, for instance, it says that on average, okay, it takes, the standard time is 2.507 minutes per carton. So if I want to set targets for my employees, okay, what should be the targets? Well, the targets should be as follows. If it takes 2.507 minutes per carton, so in 1 hour, an employee, the standard output of the employee should be 60 by 2.507, 60 minutes in 1 hour, 2.507 minutes, should be 24 package. And now we have determined a target, okay, for our employees that is not arbitrary. I didn't just, brought a number from my head and said, okay, you need to do 24 per hour, okay? This is 24 packages per hour. Otherwise, you're gonna be, penalized. No, we actually did this in a scientific manner. We took into account, whether it's in the rating factor or the allowance. We took into account whether the setting in which the experiment was carried out is normal or not. We took into account any time that the employee, is given for himself or herself that is not, going into the manufacturing or into the process, which is the allowance percentage. And this number is fair to both. It's fair to the company because the company knows that this is a number that is taking into account all of the factors, and this is a value that we can use to evaluate the performance of the employees in a fair and equitable manner. All right. So now I can use this as my standard in evaluating the performance of the employees. When I look at their, performance evaluation in the end of the month or week or year or whatever, usually do performance evaluation and to decide whether to give bonuses, for instance, whether to determine training needs. So in this case, we have now a pretty straightforward criteria. The productivity required of each employee is 24 packages per hour. So if they produce more than that, then they are outperforming everyone else and they should be rewarded. Then they will probably get a bonus. Okay. If they're producing less than that, then okay, they should be, I don't want to use the Middle Eastern way of looking at things. We always say they need to be punished. We do not punish them. They need to be probably trained. They need to be developed. Okay. And this number is set, determined based on an understanding of the process based on the performance of the employees who are doing the work. So it's not like we're getting people from outside to do this and then we ask them to do as good as those. It's taking into account all of the different, characteristics of the system that makes it different from the normal situation, and it's fair, it's equitable to everyone involved in the process. That's the idea. Any questions, my friends? Any questions on this? Is this clear? Does this make sense?
Yes.
Yes.
All right, wonderful. Okay, so at least I know Taif and Marwa are there. I don't know about the others. Okay? All right, I think we have, it's 10:57, so we're going to be discussing the practice exercises in the second half of this. Are there any further questions? No? All right,
No.
so, all right, Waad, thank you. Okay, and even everyone. So we'll